folks, you're welcome once again to another fascinating math video. In this video, we shall be considering a problem taken from logarithm. Before I go over to the solution of the problem on the board, I want to inform you that I render an online math tutoring service for the primary level, secondary level, even to the college level. And also, I render services for schools. So if you're in need of my service, be very free to get to me. If you're having a school and you're in need of a math tutor that will run for you remotely, consider me as a qualified candidate. All right, so let us look at this problem on the board. It is a logarithmic problem, and it's very easy. It's not simple. It's not a monstrosity, as some people may claim. But if you know what to do, the work will be very simple. All right, now look at it. We are required to solve the equation log to the base 4 of x or to the power of log to the base 2 of x minus 3 to the power of log to the base root 3 or sod 3 of log to the base 4 of x minus 12 equals to 0. So we are to solve this particular equation. Now we shall make use of suitable substitutions. Now if you observe it carefully, you see that each term contains the expression log to the base 4 of x. In the first term, you see it as the base, and in the second term, you see it as the index. All right, so because this term is common to both terms, we shall make substitution for it. So we can say let p be equal to log to the base 4 of x. Now it is a well-known thing that if we have a logarithmic expression such as m equals to log to the base a of n, there is an equivalent form to this expression. The equivalent form of this is by writing this antilog first. The antilog n is equals to a to the power, or to the power m, rather, to the power of m. So whenever you see this, you have this. And whenever you see this, you also have this. To indicate that, I will use a double implication sign. All right? That is a by implication sign. So this by implication sign states that whenever you have this expression, you have the equivalent expression. And whenever you have this equivalent expression, you also have this. As the converse is the case. So please, this should be strictly committed to memory because it's very useful when it comes to the work in logarithm. So that means that if we have p equals to log to the base 4 of x, the equivalent form of this is writing x equals to 4 to the power of p. All right? So in the place of this logarithmic expression, we shall put p. And in the place of s, we shall put 4 to the power of p. All right? So we put these expressions into this original equation. So in doing so, we have, for this now, we have p there. Then we have log to the base 2 of x. We have log to the base 2 of x. But our x is already 4 to the power of p. So we have 4 to the power of p. All right? Minus 3 log to the base. Now root 3 can be interpreted as 3 to the power of 1 over 2. All right? So we have it as this. So in place of log to the base 4 of x, we shall put p. Minus 12 equals to 0. Can you see that? Now this can be written as p log to the base 2. Now 4 is a second power of 2. All right? Because it's a second power of 2. This entire expression, 4 to the power of p, can be written as 2 to the power of 2p. All right? Because 4 is a second power of 2. Then we'll have this as minus 3 log to the base 3 of p squared minus 12 equals to 0. But for a moment, you may be confused. You may wonder, how come 3 to the power of 1 over 2 become p squared? Yeah, there is a law in logarithm that says that whenever we have log to the base a of x of m, this is equal to writing log to the base a of m to the power of 1 over x. All right, so whenever you have something of this nature, it becomes this. All right, and this further breaks down to writing. Now, whenever you have log to the base a of n to the power 1 over s, this can be written as log to the base a of m times 1 over x. Can you see that? So whenever you have this, it becomes this. And whenever you have this, it becomes this. So this should be committed to memory. These are laws of or rules of logarithms. And they are very, very important when it comes to logarithms. So on applying what I've just explained, this latter expression, this latter law, this particular one, if I apply this one now, the line becomes p to the power of log to the base 2 of 2 times 2p, all right? Then minus 3 log to the base 3 of p times 2 minus 12 equals to 0. Can you see that? So we have that at hand. But for moments, somehow dehydrated, let me take my drink. So you excuse me for the moment, and let me have my drink. Do you like to join me? You can come. It tastes good. All right, so we continue our study. So I will erase this part of the board now, and we shall continue the solution. Now, it is a true thing that the log to the base 2 of 2 is 1. All right, so in that case, we shall have 1 times 2p. And that leaves us with p to the power of 2p. All right, they will have minus 3. Then 2 times log to the base 3 of p can be written as 2 log to the base 3 of p because multiplication is commutative. All right, some people normally say 2 move to the backside, but I would like to tell you that there's no backside because we're dealing with a two-dimensional plane, all right? So the right thing to say is to say, since multiplication is commutative, this can be equally written as 2 log to the base 3 of p. So in applying that, we have this as 2 log to the base 3 of p, all right? Minus 12 equals to 0. Okay, now don't forget I said something. Or rather, let me quickly show you something so that you will not make the work too long. All right, look at these points. You know, from this point you see here, we have this result to be this. All right, now I would like to go back to this form again, that is transform from this into this, because it's very useful. I will tell you the reason why shortly. All right, so we have log to the base 3 of p squared. Okay, now there is a law of logarithm that says if you have a to the power log to the base a of n, that is, if this ordinary base is the same with the logarithmic base, the result becomes n. Can you see that? So in doing so, it follows that this entire result becomes p squared, all right? So that means in place of this second term, we shall write p squared. So we now have p to the power 2p minus p squared minus 12 equal to 0. Can you see that? So if this sounds interesting and you draw any value from what I'm doing, do me the favor to like the video, share the video, and also make your comments. All right? And don't forget that I offer private services for primary level students, secondary, and college. If you are in need of my service, be very free to get across to me because I'm a qualified teacher that have a practical teaching experience which spans over a decade. So be very free to get across to me. All right? So let's continue the solution of this problem. Now we shall take this negative 12 to the other side of the equation. In doing so, we have p to the power 2p minus p squared equal to 12, which can be written as 4 times 3, which can also be written as 1 times 12, which can be written finally as 2 times 6. Can you see that? Now, of these 3 forms of writing 12, we shall take only one form, which is 2 times 6. Reason being that, can you tell me the reason? You shall see that, don't worry. Now, this p to the power of 2p can be written as p to the power p all squared. You agree with me? Very simple. The minus p squared equal to, let me write 4 times 3, all right? Equals to 1 times 12 equals to 2 times 6. Don't forget, we shall pick one of the expressions. Now, if you observe carefully, this is a difference of 2 squares, all right? And in factoring, we have it as p to the power p minus p multiplied by p to the power p plus p equals to 4 times 3 equals to 1 times 12 equals to 2 times 6. Now, we cannot take this expression, reason being that this 4 you see here is a perfect square, all right? Now, the expressions, each of these expressions you see here, neither of these is a perfect square. Now, p to the power of p ought to be a perfect square, but since we are removing p from it, it's no longer a perfect square. The same thing with this. P to the power of p is a perfect, it's a perfect power rather. But in adding p to it, that deviates from being a perfect power. All right? So what do we? This particular choice will be discarded because it contains a perfect square. and there is no perfect square within the parentheses. Can you see that? All right, so this have to be discarded. Now, looking at this, 1 times 12. What is the problem with this expression? Now, this expression you see here, this cannot be 1. All right? P to the power P minus P cannot be 1. Because if we should put 1 here, for example, let's put 1, for example, we'll be having 1 to the power 1 minus 1, and that would be 0. And 0 times any number is 0. But what we're having 12 as a result. So that means it is not correct. Then if we put 2, you will see what will happen. Let's take 2, for example. We're having 2 to the power 2 minus 2. 2 to the power 2 is 4. Then minus 2 will give me 2. Can you see that? Now we have our result as 2. So you see that it is not 1. So that means that this expression ought to be discarded also. So we'll be left with only one expression, which is this. So in this case, we now have P to the power P minus P multiplied by P to the power P plus P equals to 2 times 6. So it's very simple. Now, P to the power P minus P is less than P to the power P plus P. Let me remove this out of the board first. So we can now say since P to the power P minus P is less than P to the power P plus P, we have that P to the power P minus P is invariably 2, all right? And we call that equation 1, because 2 is less than 6. Also, P to the power P plus P is invariably 6. We call this equation 2. So we solve these two resulting simultaneous equations. So in solving them, we shall make use of addition to eliminate the variable P. Now if we add equation 1 and 2, the left-hand side of equation 1 is P to the power P minus P, then plus. The left-hand side of equation 2 is P to the power P plus P. Can you see that? Then the same thing goes for the right-hand side. So we have 2 plus 6. From whence this will cancel out with this, so we're left with P to the power P plus P to the power P, which will give us 2P to the power P equals to 8. So to get the value of P, we divide through by 2. So in doing so, we have P to the power P equals to 4, all right? Now 4 can be written as a second power of 2, which is 2 to the power 2. From whence we make our equation that P equals to 2. This implies that P is equals to 2. Now don't forget, we are to solve originally an equation involving X. We are the one that introduced P into the equation. So we have to revert to substitution. And what was it? We said let P be equal to log to the base, can you remind me? 4 of X. Okay, if that is your guess, you are very, very correct. So let me remove this part of the board. Recall that P equals log to the base 4 of X, all right? So we have this, from whence we have our X equals to 4 to the power P. Do you remember this? From the initial stage. Now our P is already 2 from here. So that means that the value of my X is equal to 4 squared, and which is 16. So 16 is the answer. To check the validity of this solution, you can substitute this 16 into the original equation. You discover that the right-hand side is equal to 0 as asserted by the equation. All right, so we've come to the end of this video. Don't forget to like, share the video, and also make a comment. And also, I want to remind you that I offer a private tutoring for primary level pupils, secondary level students, and college students. Also for schools. So if you're in need of my service, be very free to get across to me. So till we meet again, bye.